Hello, this is my code showcase for ELEC240 Plymouth University for my game, student number 10656270. So, let's crack on. So my game is pretty much a version of Pac-Man, where a monster called Siren is going to chase your player character called Timmy, and Timmy has to go around the LCD and collect megaphones or speakers to their collectibles, and you've got to collect as many of them as possible before Siren gets you or touches you on the screen, and then it's game over and it will display your score of what you have. There are different difficulties using the potentiometer in the 7 segment, and I shall show you. I'll make another video with a video of me showcasing the game. Both of the links, they'll both be uploaded onto YouTube. You'll be able to see both of them. So yes, here I've included all of my different pages here. This is my main. Just a bunch of variables which I'm going to need. So let's just get into it. So the first function you can see here is a function I've made that's going to enable a collision. Actually, I think a better way to do this would just be to start from the actual game. So sets the speed to 180 megahertz. It's going to initiate the timers, initiate everything, the buttons, switches, buzzers, custom characters, stuff like that. Then it's going to start. It's going to play a tone. Buzzer start basically just plays a lower pitch and then a higher pitch tone from the buzzer, and then it plays nothing. Difficulty is the function which is going to choose your difficulty. So that's going to be in here, I believe. Or is it? Here. So here's the difficulty function. It's basically going to print on the LCD on row 0. Difficulty question mark. It's asking you what difficulty you want. It goes through the array, prints all of it. Goes through this array, prints on 7 seg. It's telling you your difficulty is shown on the 7 seg. I would make it clearer, but we only have 16 spaces on the LCD that we're working with here. So then it places on line 2. Here's a bunch of variables I'm going to need. I'll explain them later. So while the difficulty is 0, aka while it's not been set, it's going to jump into this while loop, and it's going to keep on trying to set it. It's going to read the value of the ACD, and it's going to say, okay, well, what is it? And it's going to go through this a million times a second, really fast, and it's going to keep reading the value of the potentiometer. If it's going to be less than 409, which is 1/10 of the maximum value of the potentiometer, it's 4095, I think. So I just went 409. While it's less than that, the difficulty is going to be 0. This is just so that we can. It's like a one-time if loop. So if it needs to be cleared, if the 7-segment board needs to be cleared, it will clear here, and then it doesn't need to be cleared anymore. So this will go to 0. Then it changes the value of timer 2, Arno 2 timer 2. It doubles the Arno value, which is going to make the timer twice as slow, which makes the game twice as easy, essentially, which is why this is the easiest difficulty at 0, and then it will display the number 0 here. Here it will basically do the exact same thing, but whether it's between 409 or 818, and it will do the same thing. If it needs to be clear, it will firstly make it so that 0 now does need to be cleared. If I looped back round to 0, if I went and made the potentiometer back to 409, I would need to clear the 7-segment board because it would currently say 1 instead of 0, so it would need to be cleared, so it would jump back into this if statement and clear it. Also, it's the same, a potentiometer can go up and down, so if I were to go to 2 and then go back up to 1, this would need to be cleared, so that's why that's there. So if it needs to be cleared, it will clear the segment. It no longer needs to be cleared, so it's 0, and then it does the same as last time, but makes it slightly faster, so only times it by 1.8. Makes it slower still, but just less slower. Makes it an easier difficulty. My middle difficulty is 5 here, so as you can see, it does nothing. So this is just 1 second, so every 1 second the Siren head, the monster, will move. And it will display the 5 here. And it will keep going through, and I've got 10 difficulties, as it says. I need 10 difficulties, I've got 10. That goes 0 to 9, that's 10. And the fastest is it will double the speed, make it twice as hard, essentially. It will display 9. Then I've got a blue button here. If the blue button is pressed, depending on what difficulty it's on, it will go, okay, it will initiate the timer for the new Arno value, because obviously the difficulty, change the difficulty changes the timer, so it needs to initiate the brand new timer, and then set the difficulty has been complete. It's now 1, so I can jump out of the loop, the while loop here, go back to main and continue. So I've done difficulty. I'm now going to print my start. So print is LCD, so let's go to the LCD. Print start. It's going to clear the LCD, make sure there's nothing on there. Go to line 1, print the array as you've already seen. Make an array, and then it's going to go through, press blue, all 10 characters, and print it. Same here, but for the second line. After that, it's going to go into the while loop. This is the main game loop, and it's only going to go into here if it's only going to go any further if you hold down the blue button for 2 seconds. So this is it needing to be pressed, and this is a one-time if statement again, making sure that timer and seconds. What this is it sets it takes the timer to whatever point it's on. It's going to take that point and say this is the beginning point for seconds. This is the 0th second, and then every second after that is going to increase the value of seconds by 1, and that's shown in my timers here. Every time it goes through the IQ handler, which is 1 second, or whatever the difficulty is set it is. So if its difficulty is higher, then it'll go through at half a second, and it will add 1 to the seconds there. Also, as you can see, the faster the higher the difficulty, the music is linked to it, which will make the music faster as well. So you know, the more intense the game, the faster the music. I've made them linked together. It's not worth any marks, I don't think, but I thought it was a cool touch. So yeah. So then it keeps track of the time and adds 1 to the 1 time to make it not equal 0. So it doesn't go into here again. It won't initiate the time again, because if it did that every single time, we wouldn't be able to progress anywhere, because the seconds would just go to 0, 1, 0, 1, 0, 1, keep resetting every second. So as you can see, once 2 seconds have passed here, which is why it's needed, of holding the blue button. So you have to hold the blue button for 2 seconds, then it will progress onto all of this. So and wait equals 1. Buzzer theme. This would be timers, I think. Yeah. So it makes wait equal 1. When wait is equal to 1, the buzzer theme will now play. Yay. my theme tune is now playing. It's a random theme tune every time, like a broken siren, to sort of behave like Siren Head. So I randomize the buzzer between two set pitches, and it's sort of like a broken siren, like Siren Head, my monster. So then sets the score to 0. Obviously, pretty self-explanatory. You haven't played the game yet, you haven't got any score. Starts up the LED. LED startup is over here. This is the traffic lights. So LED startups, ignore the commented out, that was when I used delays, but I changed to using interrupts because it's better. So we'll jump in, it will, the one time, and it will make timer is equal to timer, seconds equal to timer 2, so it restarts that timer, grabs that point of 0, the initial point, so it can use that same timer for this instead of the blue button. It will turn on straight away the red LED. Then after 1 second has passed here, it will turn off the red and it will turn on the orange. And after 2 seconds, it will turn off the orange and turn on the green. And it will turn off the green after another second has passed, 3 seconds. That's all that does. So we've gone through the traffic light sequence. LCD clear, just going to clear the LCD of the print start here because we're going to need it. It's going to begin. Now begin equals 1 is going to allow the game to begin as shown here. That needs to be 1. Pushed is going to be equal to 0. Now where is this used? Hold on, I know how to do this. So it's going to set pushed to 0, which I'm sure needs to happen. I'll get it eventually and I'll be like, oh yes, of course. Ah, here we are. So it's in the ADCD stuff. Oh yes, of course, it's used for the blue button, isn't it? So yeah, when the blue button is not pushed, it is 0, so it makes it so that the blue button is doesn't loop back around to it. Let's make sure that it stays into this. So this is just setting spawn points or coordinates for S is Siren Head is the monster. Then it puts the cursor onto that coordinate there, and then it places the monster. And this does the same here, but with T for Timmy, which is your playable character. Then begin is equal to 1 after up here, so it will begin the game. We're going to equate pushed to all of the switches. So the switch D, B, A, and C on the board all have been defined in switch.h. If I find that quickly, here we are. They've all been defined as the actual as the actual pin here. so that it's just easier than writing this out. I can just write switch D. So pushed is now equal to that, so I can just write instead pushed. If D, the D is pushed, then you move right. If B is pushed, then you move left. If A is pushed, then you move up, and if C is pushed, then you move down. These are all values I find using the debugger of what the values of the buttons are when you push them down. I should go over these functions here: move right, move left, move up, move down. And they are all in switch.c. So I should go over my locate function as well. That's probably a good idea. So basically, I've got a row and a column, which enables me to just set, when I reference locate, the row and the column by placing a number on this side of the bracket and then a number on that side of the bracket. So if the row is equal to 1, it's going to place, if row is equal to 0, it's going to place something on the first row, the top part of the LCD, and command LCD, and the hex here is given in the LCDH as a definite thing here. That is how you reference the rows, and then it's going to be plus whatever is on the column, and then this is the second row. So if I want to move right, like it is in the character movement, it's going to add 1 to whatever the spawn point is, if assuming you move this first, or whatever the coordinate is for Timmy, the playable character. It's then going to place him in this, and adding 1 on the X is going to make him move right by 1. It's going to then place him in, put the cursor in that position, technically a cursor, and then place Timmy. It's then going to backtrack by minusing 1 from the X coordinate of Timmy, going back to his original position and placing a blank space, which is 20 is the ASCII for a blank space. So it gives the impression on the LCD that he has moved to the right. The left, the up, and the down functions are all the same. So for left, he'll go be minus, and this will be plus. For up and down, I haven't done plus and minus. I've just done 0 and 1 because there's only 2 rows on our LCD. It only needs to be 0 and 1. It takes away, errors and bugs and stuff. But they're the same as before. So back here, we've got all of that lovely jubbly. Now we've got the speaker AI. Speakers are the collectibles in my game. They're going to spawn around the map randomly every 10 seconds. This is also in my Switch. So speaker AI is here. This is basically going to, every 10 seconds, spawn a speaker. So it's going to locate, and it's going to clear the space the speaker is meant to be. This is because every 10 seconds I've added a feature to the game where if you haven't collected it after 10 seconds, it gets rid of it. So that's why this is in the beginning. So it gets rid of the speaker, and then after 10 seconds it will place another one. It will find a random coordinate on the LCD between 15 and 0 for the X, between 1 and 0 for the Y, and it'll place it. And when there's just a little bit of collision avoidance here, it cannot place it in the same place as Siren Head. So if the X coordinate and the Y coordinate of where it's going to place this speaker is the same as the X coordinate and the Y coordinate of my monster Siren Head, it will find another random variable and will not place there. So just a bit of debugging or whatever you would call that. Then it's going to place the cursor in that place, and it's going to place the collectible, and then touched is equal to 0. This is basically makes it so that the collectible has just spawned, it has not been touched, therefore it is 0, and it's going to take the 0 point in the timer, it's going to equal it to seconds again. Then it loops back around. This then leads us to the set score function, I believe. Yes, set score. So if the Timmy playable character is equal to the microphone, the collectible, on both the X and the Y axes, and the microphone collectible has not been touched yet, which is why this is a 0, the score will go up. Touched will go up, so it means it has been touched, so he cannot infinitely collect that collectible. And the score will display. And this initiates the blue button here, as you can see. It probably already went through that. So the score will display. Now what that means is, if we go into my timers, timer 2 handler, I've already told you about how every second, or whatever actually the difficulty is set to, the ARR, the buzzer theme will play, and buzzer theme is basically a random pitch, and it will then initiate it at the random pitch, which I believe I've already said. Then if the game is on, so if begin is even on, the game is playing, Siren Head AI will play. Siren Head AI is in Switch as well. This is the AI for my monster. So he's essentially got the same movement mechanics as my playable character, but he does it on his own. It takes a random number between 1 and 4 and makes it equal to movement. Now movement is 4 if statements here for 1, 2, 3, and 4. If movement is equal to 1, he's going to move to the right. This is a little bit of barriers so that he doesn't, stroll off of the edge of the LCD. If he's max on the far right of the LCD on place 15, he's going to move back to the left, and he's going to cursor locate there. He's going to be placed in that one place on the left, and a blank space is going to be pressed on the right. And this is if he was going to move right, and then he moves right. So after all this code has been done, essentially nothing has happened. He's not moved, but what's actually happened is he's moved left and he's moved right again, so he ends up in the same place. And then the code will loop back around again until the random chooses for him to move somewhere which isn't to the right, which isn't moving off the LCD, and he will move in that direction. Movement 2 has the same boundaries, but if he's so far to the left that there's nothing left, he'll move right, and then he'll move left again, and essentially nothing has happened. And then it will do the whole thing, go back around, give a random number, say it's 3, and instead of going left, it'll go up, and that's not sorted, or right. 3 and 4 are nice and easy. This is up and down. He goes to position. This Y corner goes to 0. He's placed there. If he's going up, Y corner goes to 1, and he's placed there. He's going down because there's only 2 rows. And that's the AI for Siren Head. Then show score. Is that the one I already went through? No, I haven't done show score yet. So show score, I believe, is in my ADCD stuff. No, it's not. Where is that? It is going to be here it is in the LCD.c. So show score, which is in a timer, is going to happen every second. It's going to see if the score is meant to be displayed, which is 1, and the score is meant to be displayed is if you can, as you saw earlier in switch.c. Basically, if sorry, my timers. If I've lost my train of thought. So if show score display equals 0, so I went into show score, and I went into here, and score display is equal to 1. Score display is equal to 1 if yes, okay, so if the score has gone up, score display will equal 1. So the score's gone up, but it needs to be shown. Where is it going to be shown? Well, this is the function show score that's going to do that. It's going to be shown here. So it's going to locate the y and the x coordinates for the score to be shown. Then it's got an array. This is a converter from a char to an int, so it's going to basically make it so that I can print numbers instead of letters. So 0 and a 1 and a 2, 2, 3, whatever. It's going to be 3 characters. It's going to be a tens and a units, and then this is the terminator of the string. So it's basically 2 numbers long. So it'll be a 0 and a 1 if the score is 1. If the score is 12, it'll be a 1 and a 2. Then it goes through that array with this for loop, prints the score when it needs to. When show score is called, which would be when the score has gone up, it will show the score. So it places the score is going to be shown here, and then when the score does not need to be shown, which would be when this has sort of gone through, it gets rid of the score. And this is going to happen every second. So show score will happen every second. So essentially, every second it's going to see if Timmy has picked up a collectible. And if Timmy has picked up a collectible, it's going to show the score in that one place for 1 second. And then, after that 1 second, show score, display score goes to 0. Like here, because it does it every second. So then it's going to, in show score, it's going to get rid of the score being displayed, so that it doesn't take up the playroom. It's just going to have enough playroom there for you to go around. It doesn't keep the score, and it just shows it intermittently. Places blank spaces there. Then what else do we have? The timer. Been over that. Excuse me. Let me go back to our main. What have we got? Where were we? We've been over that. Now we're on collision and set score. We already did that, so we're on collision. So collision is just up here. Basically, if my character and the monster touch, if they're in the same coordinates, the game's going to end, so begin's going to go. This while loop is no longer going to take place. It's going to clear the LCD and it's going to print end. End is simply just saying you played the game. It's going to say game over. It's going to print that array. It's then going to say my name and then the score, and then we've got another char to int converter here. It's going to print the score because it's just printing the variable score instead of an actual number, same as before actually. Yeah, it's gonna show that at the end of the game. So I'll just quickly go through all of my files to make sure I haven't missed anything. These are delays so the LCD can catch up. Make sure that we don't do anything too fast for it. This is going to make the LCD flash very fast. This puts something on the LCD in the closest available space. These are all my custom characters. I forgot about that. So basically, this is binary for places on the 5x8 blocks, on each of the 5x8 blocks, and these places in binary link to certain places on the 5x8 block, and they're going to light up and create those pixels are going to light up and create my custom character. The there's 3 here. There's the Siren Head, the monster, there's Timmy, the playable character, and there's Megaphone, the collectible. And then all of these are going to go through this loop. From there, you're going to place this one. They're going to place it. This eye is going to go up. Then I'm going to place this one. This is an array again, and an eye is going to go up, and then I'm going to place this one. And an eye is going to go up, and then place this one. Like quite methodically and in order. So that procs every time I want to move the character. This is initializing the LED, the LCD, sorry, which we were given this. And if we go, then we go to my delays. I didn't really do any delays because they mess up the timers, so I just kept it simple. I got a 1 second delay here, but I haven't really used it anywhere, so it's not really any point being here, but it shows that I have used delays, I suppose. My LEDs, yes, the 7 segment. So how I've done the 7 segment is I've initiated all my LEDs here, by the way. 7 segment ones are here. So this is basically going to clear all of them, it's going to enable all of them, and then 10 is going to enable me to actually use the one on the left and the right, and then 15 is going to make it so that the latch is like open, so I can actually use them, so they actually turn on. This is actually making it turn on. If this wasn't here, they wouldn't be able to. They wouldn't light up. So LED idle is just a function that I had while testing. It uses the 1 second delays. It's not anywhere in my code, in my main, it doesn't run. Just something I was using to test. So all of these functions making it so that when I want to like call the number 1, it's like 1. It's gonna make this equal to number 1. So it's gonna make all the 7 segment LEDs, all of them equal to number 1. And number 1 is up here. Number 1 is going to make all of the 7 segment LEDs equal to this, which is just 2 of them being on. When I want number 4, say, all I have to do is write 4 bracket bracket semicolon. It's going to make all of the 7 segment LEDs equal to this variable, and that variable is equal to number 4. It's equal to here, so it's going to turn on that LED, that LED, that LED, and that LED. Which I'll just have a look for number 4. They are going to be F, G, B and C, I believe. F, G, B and C, yeah. So these numbers count to F, G, B and C. It just took me a while to look at the numbers there. So that's how I've done my 7 segment, and that's how I got that to work. We go into timers. I've initiated my timers here. So this enables the clock, and then it's enables the interrupt, so I can use the interrupts. This is basically setting, all in all, this is setting the clock speed, how fast it goes with some maths off of the 180 megahertz timer of the processor. Excuse me, it's quite late. It's going to 0 the counter, and it's going to enable global interrupts, so I can use interrupts anywhere, and it's going to start the timer. The same is for timer 2, except this is a 128 megabit timer, this is a 256, so this one can keep timer for longer. They have different numbers here to enable the global interrupts. This is the handle for 3, just turns on the buzzer. This is the little starting doo-doo that will play, and this enables it. This very clears the interrupt service register, so that's free to go. Then this, I've already been through it, but plays my theme and goes through everything every second, and then adds 1 to the seconds, so that the seconds variable is always correct. That doesn't matter. That does nothing. We've been through everything in my switch.c. You just see coordinates. movement, I've been through score, I've been through touch, I've been through score display, I've been through initiates my switches, I've been through locate, I've done my movements, I've done Siren head AI, I've done speaker AI, I've done that, I've done that, I've done buzzer stuff. So initiates the buzzer, enables the buzzer. This just turns the buzzer on. That was just a testing thing. This is what actually, this just turns the buzzer on so it can be used. This is the little jingle in the beginning, the lower pitch and the higher pitch. Every time you change the ARR, you need to initiate the timer again, and it's a second delay. So I have used delays here actually. So it uses it for 1 second delay, and then it changes the ARR. And this 0 makes the buzzer stop, so it initiates nothing. Essentially makes the buzzer turn off. Buzzer theme is the random number between 100 and 500, and then initiates it so that every 1 second in the timer 3 it's going to change the pitch of the buzzer. And here I've been over everything. This initiate, all of this initiates ADC and then the DAC here. I had to change the channel in the H1 to actually match the 0 what it says on the board. It's going to, this is it reading the ADC. I don't actually use DACs in my game, so they're just sort of there. This is the difficulty function that I already went over, and I went over that as well. So yes, that is all of the code really. Obviously it's going to be uploaded, and I've commented it to the best of my ability. Pretty much all of it is commented. Well, actually all of it is commented, so you should be able to go over it yourself. But there's the video of me explaining it. Thank you very much. Goodbye.